Hey everyone, we're going to go ahead and do the demonstration for the third week on projections and coordinate systems. I've already gone ahead and downloaded my demo data and created a folder on my G drive, my Google Drive with the like a Lab 3 folder. So I'm just going to go ahead and create a new map document to live within there. I'm going to call this 3, we'll call it projections. Oops, not G projections, projections. And I'm just going to put it off in my drive. This PC. Put it right in there. And I already created the folder, like I said, so I'm just putting it in there. I'm not going to create its own folder so that it all lives in the same spot. I'm just calling it the same thing. And then as usual, we're going to start adding in some of our data. For this particular demo, I just want to make a couple of things clear. We're going to be doing some georeferencing at the beginning off of scanned coordinates, scanned quad sheets. In fact, it's one quad sheet split into two parts. That's for the South Bend quad. That is the only time you will need to do that part, this first part. I'm not going to have you repeat that process because it's not something that gets done a huge amount, but I wanted you to at least see how to do it. So what I mean by those, I'm going to go ahead and go into folders here. This is just a catalog tab that's up. And I'm looking for the South Bend East Quad and South Bend East Quad 1 and East Quad 2. I've just tab clicked or Control Shift clicked on both of them. I'm just dragging them in. It should presumably give me a warning at some point. Yep, there we go. So it's calculating statistics to begin with. It's brought them in. And you see up at the top of my screen here, it just popped up with unknown coordinate systems. And we don't actually see these things anywhere. And that's because they're just scanned images. They have no coordinates. They have not been georeferenced or rectified or anything yet. And in fact, if I right click on one and go to zoom to layer, you see that it's sort of floating somewhere in sort of around 0 latitude, 0 longitude, sort of point off the west coast of Africa, the 0 longitude, 0 latitude. So our first step here is we're going to georeference these things so that they fit in the right spot. Because if you look at them, if you zoom in on the corners here, you see that it has a bunch of this information that we talked about before. It has the North American datum, 1927. It's got the 83 one as well. In this case, the corners are the 27. So we're going to work with those. It's an older map. And then there's other pieces that they're on here as by sort of dashed things. So we can kind of leave those as is. So the first thing we want to do is we know that this is in a geographic coordinate system because we see latitude and longitude using the North American datum of 1927. We want to set what our map document is so that it knows to interpret the coordinates properly. And we do that again, like I showed a little bit quickly last week in map here. And go down to the coordinate system tab. It's going to always default to this WGS 1984 Web Mercator. That is, if you remember from me saying this in class, that's the Google Maps base map layer. That's sort of what web mapping is all done with. But in this case, we're going to do something different. We're going to go through geographic coordinate systems, North America, US and territories, and then NAD 1927. Because this is a geographic coordinate system, it doesn't tell you a projection. It's just latitude and longitude. So we're going to do that one. And then we're going to hit OK. And it'll jump around a little bit as it tries to interpret those coordinates. And in fact, if I zoom to layer on it, now instead of being tiny down at the equator, it's interpreting the pixel numbers as degrees, which is why the entire world is up here and the map is, 100 times bigger than it, because it's wrapping around the globe thousands or hundreds of times. So obviously that's not correct. What we need to do now is set these things in place so that we enter in these coordinates. And we're going to do this through something up here that we haven't touched yet called the imagery tab. So if we choose imagery, as long as we have the raster layer selected, and then we have this georeference button. That will bring up this new little tab right here called georeference. There's a couple things we want to do to begin with. The first thing is in transformation. Just make sure that it's chosen first order polynomial affine. You see, we talked about this before where we can just do some real simple things in these second and third. And then these are these interpolations and other things down here. And it tells us that we need three control points to do it, four to do it properly. Don't try to click any of these other things at auto georeference or import control points. Those can work for more advanced things, but this is just a scanned map. What we want to do now is choose, well, first I'm just going to zoom in on the bottom corner so that it's ready for me here. Because this is the coordinate I'm going to enter in right here. On these sorts of maps, it's important to know that this is latitude. It's the bottom of the map. This is longitude. It's sort of the east-west. And this is if minutes is not less listed, so 86 degrees, 15 minutes, it's implied that's 0 seconds. 41 degrees, 37 minutes, 30 seconds. North latitude, west longitude. So my very first step on this one, making sure that I'm selected quad 1 over here, is I'm going to go to add control points. That'll bring in here this thing where I have the little crosshairs, and I'm just going to run it over to that corner, click once. Now what it's saying is I could click again to point it to something if I had a feature in common, but in this case I have numbers in common, or I have the numbers printed on it. So rather than do anything else, I'm just going to right click, and that'll give me this thing that I can bring up target coordinates here. I'm going to choose it over to show coordinates in degrees, minutes, seconds. It's going to yell at me because it's out of bounds because where it's defaulted is really, really far. And so this is my longitude is 86, 15, 0, west. My latitude is 41, 37, 30, north. Then I'm going to hit OK. It's disappeared because it's moved it to that spot. If I still zoom to the layer, you'll notice that it's still bigger than the entire world, but it's moved it so that that point is in common. So my next step is just to find the next corner. Sorry, for whatever reason that failed on me. Sometimes if this happens, you can just press this button right here. It refreshes the view. I don't know why that wasn't letting me zoom in on it. I feel like my pyramids probably failed. Oh, no, there it is. So I'm going to zoom to layer again. Probably just taking it a second to render properly, but on the off chance that it's not, I can always just go back over to my map and sort of go back to a zoom that worked before. I can do my like fixed zoom in, fixed zoom out, that kind of stuff to see where and why it's failing on me there. Something about the free zoom wasn't working real well there. If I have a mouse wheel, I can actually use the middle probes. I did it wrong that time. Or I can just sort of pan myself down so I can see it. Yeah, something just wasn't working with the corner over there. Just give it a second to see what will happen. Okay, well, I never got it to work quite right, but I'm zoomed out at this level. This is all right. Get on my corner there, click again. This will read my coordinates, degrees, minutes, seconds. It's annoyed with me for that because it's still very big. I can see in there that that is an 86, 7, 7. Oh, I don't know why it's sending me down. West. and then a 41, 37, 30 north. Now when I hit OK, it disappears again. And if I zoom to that layer, you'll now see that it's largely in the right spot. It's not perfectly lined up. You can see that the river is elongated up. That's because it's in degrees, minutes, seconds, and it's on top of something that's in meters. We're going to fix that. We're going to squish it back down now. So we have to find the last two coordinates on this map. And where they actually are is sort of printed up the side of the map itself here. So I'm going to go back over to georeference. And it's actually this coordinate right here. So what that's saying is that's 40 degrees. And if we were to click on it, which did not. So if you don't like a point, you could just hit escape to get out of it. So I'm going to click right there on the edge of the map and at the 40. And what that's actually saying is that's 40 minutes right there. So it's not repeating because print used to be expensive. So it's saying that's 41, 40, 0. And then the 86 is still the same. So I can just enter that in right here. So 86, it's actually gotten pretty good at it. 86, 7, it's 30 west instead. And then that was 41, 40, 0 north. You see that squished it down just a little bit. So now this is actually pretty accurately georeferenced. You can look at it against the river and everything there. It's not, perfect because maps are different times. But we do want to just to be able to double check it off of that root mean square, come over to the other side and do that other 40, just to sort of see where that comes up when we put it in. So I'm going to click right there on it. And it should default pretty well. This is, if I were to scroll back down, this would be 86, 15, 0, 41, 40, 0. Hit OK. Barely moved it at all. And now, if I want to assess how good that is, I'm going to go to this control point table thing here. And that'll tell me the original coordinates in the image, the map coordinates. You want to make sure that those look like a square, and then the residual on them. And it's like 0.000041 in X and about the same in Y. That's actually really good. If it's in meters, you want to be less than like 10 meters or so, or whatever the resolution of the image is. If it's in this thing, if it's in latitude and longitude, then this many digits is usually pretty good. So now when this is done, if I like it, I can hit save. And it's now georeferenced. That JPEG image just has a separate file with it that tells it how to display it and how to do things, and it's pretty well good to go. So once I've hit save, I could also hit save as new and just save a totally new file. I'm not going to do that for these because we don't really need them again. I'm just going to repeat the exact same thing over again for the South Bend 2 quad. So with that selected, I'm going to go to zoom to layer. I'm going to zoom in on a corner at the top here. I'm just going to close this down so I can see a little bit better. And one thing that you may notice, whoops, right off the bat, is that because of Michigan, it's not perfectly along the edge there. The edge of the quad should be right here. They push it up just a little bit because the edge, like this is the border in Michigan, so why? Like if there's county border there, they just include the extra piece. So we don't have a perfect corner, but what we have is that this is 41 degrees, 45 minutes, 0 seconds north, and then this line is 86, 15, 0. So if I come down to here, that's going to be my first point. Do you want to make sure I've selected the right map layer over here? And I think I need to go back to imagery and start georeferencing again. Well, no, I've actually already got it up, so I'm just going to do that. I think it'll work. I'm going to add a control point. Click on my spot. Show coordinates. Yells at me slightly. So my longitude again, 86, 15, 0, west, 41, 45, 0, north. Should disappear on me? Yeah, I think it's still georeferencing the wrong one. So what I'm going to do, so I think what has to happen is that I have to restart the georeferencer pointing at the other image. So I'm going to close here. I'm not going to save my edits because I'd already saved it once. So it should still have South Bend Quad 1. I'm just going to zoom back to it. Still in the right spot. Everything's good. Now I'm going to go back into South Bend Quad 2. Go to imagery, choose georeference. Set my transformation. Add control point. And I'm going to go back to that same spot. Just do the same thing over again. Just getting those visible. Oh, just one more time here. So 86, 15, 0, 41, 45, 0. And then those should be north and west. Now it moved it accurately. That's what I wanted it to do. So I'm just going to scroll myself over here. It's doing the same thing I was doing last time. Must be something about it getting wrapped around the world too many times when it's in degrees. So just going to do the same thing. Get it in just enough that I can see what's going on. Get my point the best I can. And then we're going to do, so it's got to at least that it's north this time from the default, and that's 41. Should be the same as the other one. Square, rectangle, and then 86, 7, 30, west and north. Zoom into my layer again. Sure enough, we're in a much, much better spot. Gonna find one of those other coordinates. Remember, this is 40 degrees, 42 minutes, 30 seconds. Gonna enter that one in. It's got 86, 730. Did that one just fine. And then it's 40. Sorry, so this should be 41, 42, I think. We'll find out in a second if it messes everything up. Yep, I think that should be good. And then we would do the third one to sort of assess it with our root mean square and everything. Okay, so I just double clicked real sillily and created a point that didn't mean anything. If I do that, I can always go to my control points, find the one that isn't good, and then just hit this thing to delete it. So that's what I just did there, because this is the one I was actually looking for. What I didn't put one, there we go. 86, 15, 0. I just remember that from the first one, and it was the one that was closest to it. And then 30 north. And you see I still have a pretty good residual here. I'm pretty happy with that. I think I'm good to go on this one. I'll hit save on that too. And now comes the moment of truth where I have both of these things. And I'm going to turn them both on and sort of assess how well they overlap. If you put one on top of two, this is pretty common with scan stuff. You get things that have those weird artifacts. That's exactly what that is. But as I sort of zoom in and out, I could swipe, I could do other things to just sort of see if they line up okay. They actually look like they're pretty good. So I'm actually pretty content with those. If you get ones that are smeared, things like that, just delete ones that were there and you should be fine to fix the points. Make sure that they line up properly and you should be good to go. Okay, so I'm going to close my georeferencer on this. And our next step with this quad sheet, and again, this is the demo part, is the only thing you're going to be doing this on. I want to mosaic these together so that I end up with one image that's both of them kind of combined into one. This is real common if you have to scan things. This is real common if you get stuff that comes in different chunks. So I just want to make sure y'all see this particular function. I get to it in analysis, raster tools, which are sort of hidden in here somewhere. So analysis, raster functions. Sorry, I've got Zoom windows up all over the place. It's over at the end here. If I go into raster functions, I could go through these and find them if I wanted to, but I could also just type in the word mosaic. I'm going to mosaic rasters, bring over 1 and 2. The other thing I could do is just select them from up here. Remember, if 1 is on top of 2, it lines up right. So the operation is what to do with overlapping areas. I'm going to choose first. It's going to output it as a raster layer. I'm going to create a new layer. This is temporarily saving it within my database, so I will probably want to save it permanently at some point. And what you'll notice is that that one is now all of it together. The last thing I want y'all to see here, and this is something you will do again after this point, is what to do with this thing, because it is currently here as just a regular latitude and longitude stored file. We do want to reproject it from that NAD27 into WGS84 and then in our UTM zone. So we're going to go ahead and do the reprojection on it as well. So we can get to get this in a number of different ways. It would have been in raster functions probably too, but we can also hit this tools button for on analysis tools. This is called the Arc toolbox. This has all sorts of things. If you do stuff a lot, it'll show up in favorites. But I would start with toolbox. You have a custom one you want as well. But I'm going to tell you throughout the class how to get to a lot of these things. In this case, reprojections are in the main part. They're in data management. There's a section further down there called projections and transformations. You're going to probably immediately think to go to project, but you actually go into raster and then it's project raster, not project raster. That'll bring up the tool. We're going to tell it to take that mosaic one. It's going to give us an output name of mosaic rasters project raster. I'm going to give that an actual decent name. You can leave it in the geodatabase if you want. You can also just create it as a TIFF file if you want. And I'm going to call it South Bend quad UTM. And then I'm going to go into my output coordinate system. I'm going to press this little thing onto the side here. And this is where I was saying in class that we're going to repeat this over and over again. We're going to go through to get to the UTM, WGS84, projected coordinate systems, UTM. Oh, sorry. It's WGS84, Northern Hemisphere. And then we're looking for zone 16 north, which is right there. It'll automatically like default out to what the transportations are, the resampling technique. This is fine to leave in nearest neighbor, output resolution, all this stuff we could do if we wanted to, but I'm just going to leave it and hit run. It's not going to look dramatically different, to be honest, when it comes in, because it's already kind of reprojecting it on the fly, but now it's stored the way that it's supposed to be, and we'll render a lot more quickly. So it's running a little bit. It takes it a few seconds to do this. Rather than just sort of wait while it gets everything up and going. It's because it's got to resample every pixel in there and then save it on my Google Drive, which could be a little slow. I'm going to show the next part that we're going to do as well, because the other thing that I talked about was that we can do these things from imagery to imagery. And if we find our catalog tab, wherever it might be on here, there's mine. You'll notice that I also gave you this aerial imagery JPEGs in here. Those are just what you would expect. They're aerial images that are not georeferenced. If you ever want to see if something's still running, you can just come back over to the tab, and it'll eventually get run. But I want to georeference these things, but I want to use the UTM system to do it. So to do that properly, what I need to do is have my coordinate system already in UTM, have my map document already in UTM. I could change this back over if I wanted to. I just as easily, I could just create a new map document, and whenever this thing is done saving, I just add that in and it'll default to that. So just so you all get familiar with working with multiple map documents, I can go up to map, I'm sorry, insert, new map. So I have map and map one. I could come over here and like slow click on map one, and I could rename this as UTM or something like that, just so I know why this one's different. And then I could go set my coordinate system as projected UTM WGS84, Northern Hemisphere, Zone 16 North. One thing that might be useful if you're working on your own personal computer, just right click on that and choose add to favorites. And now it'll show up at the top of the screen every single time, which is pretty slick that it's in there. See, I've got a couple of mine already in. So it doesn't really change anything other than making it so that you can't see anything but your UTM zone. So we can't zoom out all the way, but that's the kind of place that we want to be working. And then the next thing we're going to do, so I'm just seeing, I don't know why this is not finishing. I'm just checking the specifics on it. We'll just leave it running for a while. It's not the end of the world if it doesn't, because there's some ways around it. So we're going to add in that aerial 1988. I'm going to start with Notre Dame. You can do whichever one you want. It's also ungeoreferenced. So if I zoom to it, I'm way down, like in the middle of nowhere on it. In fact, I'm off. That's a different one. Yeah, I'm at 0, somewhere off the coast of South America on that image. So I want to be able to georeference this thing, but I need something else to georeference it to because it doesn't have coordinates printed on it. I could probably use the base map here. That would probably be just fine. I could use that quad sheet if I downloaded it. And that's what the demo notes sort of suggest. But I want to show you all a trick. Going from imagery to imagery is much, much easier than going from imagery to like a printed map. So I'm just going to add a folder connection here. I just right-clicked on folders. And I'm just going to add, I think I've already done this, just the root directory to my GIS folder. So I can go find some of the other raster data that I have. So if you remember in Lab 1 raster, I gave y'all a bunch of Landsat and spot raster data. I just happen to know that the spot is probably the best. So if you bring in your spot data, that is georeferenced. And if I zoom to it, you can see where it is. Remember that the Notre Dame one is just off slightly. And if I zoom to that aerial image, which is very, very far away, I don't know why it's calculating extents on me and stuff right now. Man, so it's not behaving today. Yeah, so I've zoomed there. And what I want to do is find places that are in common between them. So I'm going to try to find things that I think will be easy to spot in between two different images. So I'm going to do, we'll do the bottom corner of the library right there. That should be pretty obvious on Notre Dame campus. I'm going to start georeferencing here. Okay, so as I was starting to say, with aerial chosen over here, I'm going to go to imagery again, georeferencing. I'm gonna just right click over here and go to zoom to layer. And I forgot to do this earlier, but if I hit fit to display, it should actually move it over there so that it's in the right spot already, which is pretty handy because now it's actually much, much easier to see back and forth between them. So you can start to see kind of where things line up. And in fact, you can probably start to pick out some of the spots that we might be able to use in common between them. So like I said before, I'm going to start off with turn off my spot image because I want to start with the right one. And I'm going to come over and I'm going to do the bottom right corner of the line. Actually, maybe I'll just do this intersection up here. Road intersections are a little better. So I'm going to do right there. Then I'm going to turn my spot image back on. This is a case where swipe might actually work pretty well. Because of course now I'm having trouble finding it. Oh, it's right. It's this one right here. So with one, it's moved the image to the spot, but you can still see that it's pretty distorted in a lot of ways. So I'm going to come down and I'm going to find, ideally we want to try to find something that's in like well distributed across the image. So I'm going to come over here and again with my aerial, you can see it's a high resolution image. I'm going to come in here and just trying to find a spot that I know I can see between them. So that intersection right there is that right there. Now you can see my images are starting to line up a little bit, but they're still a little bit skewed. And in fact, it's usually a good indicator of that when it starts not being a rectangle. So I'm going to see what I can find over in this corner. Just try to pull it back down. So there's that parking lot right there. All the way up there. So that kind of curvy thing coming out. There's a golf course right here. So I think that that corner of that golf course right there is that corner right there. And now you can see my stuff is starting to line up pretty well. And if I go and find fourth corner on it, becomes a little bit more obvious what's going on. So let's see, some of these roads are new between when the two images were taken. So it makes it a little bit harder. Not undoable. Yeah, so now I could find like right there is basically just right there. And I would say that those are pretty well referenced now, and I can save. And in this case, I might actually want to hit save as new, save this thing as an output somewhere permanent. I'll go through that in the demo as well, though. So that's it for that. The very last thing that I wanted to show y'all, I've saved it, so I'm going to close my georeferencer, is this concept of clipping rasters. We're going to do this a lot later on, so I just want you to get an early handle on it. We're going to go back into analysis tools. Actually, first, before we get there, so I gave you in here also this parks outline shapefile. These are just outlines of the sort of study areas for all of the different parks. You just want to select the one that you're working with. This is Notre Dame. It's also in the attribute table if you want to do it that way. And then analysis, raster functions. This one is called crop. Oh, sorry, clip raster. So what we're doing is we're going to have a raster It's going to be, any of these is fine. Just use whatever one we want to start with. Clip the things inside. We're going to do parks outline. Um, use input features for clipping geometry. And it should be good to go if I create a new layer from it there. So now what we have is a piece that is just what was inside that box. So it gives us kind of a cut down version of it. Okay, so those are the big things that I want y'all to take away from. There is a section about downloading quad sheets. I can pretty much guarantee you that the various ways you download those are down right now while I'm recording this. I'll try to do those in the future lab, but there is a box folder that should have all the stuff you need to get the quad sheets for your park. Remember, you do not need to georeference those. You just need to reproject them. The only things you should be georeferencing are the two pieces of the South Bend quad sheet. Otherwise, good luck with everything, and please feel free to reach out if you have any questions.